We're going to use the same properties of logarithms that we've previously talked about to expand these. They're the exact same properties. These problems are just going to be a little more complicated. So the first thing that I might do is I'm going to notice that I have a square root in this problem. Well, recall that we can replace any square root with a 1/2 exponent. So rather than say the square root of x squared plus 1, I'm going to put x squared plus 1 in its own parentheses and just raise that to the 1/2 power. Any square root is the same thing as a 1/2 power, so I can kind of now ignore that piece of the problem. So what I have then is two pieces being multiplied together. I've got this x times this x squared plus 1 to the 1/2. So what I think I'll do is I'll start by separating those out. So I'm going to write this as log base 3 of x. Now remember, a multiplication problem separates or expands into an addition problem. So plus log base 3 of, and then this whole piece, the x squared plus 1 raised to the 1/2. Well, one more thing I can do to expand this a little bit further, recall that any exponent can be moved to the front and become just a coefficient multiplier. So I'm going to go ahead and do that. So this first piece is already done. It's just log base 3 of x. That's as expanded as that can be. My second piece, though, will now be plus 1/2. Because that came from my square root, the 1/2 exponent, times log base 3 of x squared plus 1. Now there's nothing else I can do with that parentheses. I can't separate that part out. So this becomes my expanded expression. For our next example, we have the natural log of two pieces that are being divided. Well, again, let's begin this problem by separating this out. To separate a division problem, we separate that using subtraction. So I'll do the natural log of x squared minus the natural log of x minus 1 to the 3rd power. So those two pieces, anytime we had division before, we separated with subtraction. It's still the same on these problems here. Similar to what we did on the first example, to finish it, let's take any exponents we have and swing them to the front. Those become multipliers in the front of these expressions. So my final expanded expression is going to be 2 times the natural log of x minus 3 times the natural log of x minus 1. And once again, I cannot separate those exponents, or those parentheses, those terms in parentheses. So this is my expanded expression.